So, it turns out that an entire lost continent has been lurking beneath the ocean, and scientists are absolutely stunned by what they've found. Not just a random island chain or an underwater plateau, this is a fully fledged continental structure, stretching thousands of miles under the waves, a forgotten piece of Earth's history that was hiding in plain sight. The idea that a whole continent could disappear and remain undiscovered for so long sounds like something straight out of science fiction, but the evidence is mounting, and geologists are scrambling to understand what this means for our planet's past. The discovery wasn't made in a single eureka moment. Instead, it was the result of years, decades, even, of careful geological research, deep-sea mapping, and satellite imaging, slowly piecing together the clues that hinted at something massive hidden beneath the surface. Scientists have long suspected that the ocean floor holds many secrets, but this was on a different scale entirely. What they found wasn't just a submerged landmass, but an entire continental fragment with all the hallmarks of a true continent: a thick crust distinct from oceanic plates, complex geological formations, and even what appear to be ancient mountain ridges buried under layers of sediment. To understand why this is such a groundbreaking discovery, we need to talk about what actually defines a continent. Most people think of continents as just the large land masses we see on maps: North America, South America, Africa, and so on. But geologists have a much stricter definition. A continent isn't just land above water. It has to have certain characteristics that set it apart from the oceanic crust. Continental crust is thicker and less dense than oceanic crust, and it's usually made of different types of rock, like granite instead of basalt. That's why continents float higher on the Earth's mantle compared to oceanic plates. When scientists started analyzing the geological composition of this newly discovered landmass, they found that it checked every single box. At first, researchers were skeptical. After all, how could we have missed something this big? We've mapped the entire surface of the Moon and Mars in greater detail than the bottom of our own oceans, but still, a whole continent slipping under the radar for so long seemed impossible. However, the more data they collected, the more undeniable it became. This wasn't just an underwater plateau or an oversized island shelf. This was something much, much bigger. They tentatively named it Pacifica, and its existence is already challenging our understanding of Earth's ancient geography. But that raises the next big question: how does an entire continent just disappear? Continents don't simply sink like a stone in water, so something catastrophic must have happened. The leading theory? Tectonic forces, the same forces that create mountains, earthquakes, and volcanic eruptions, may have played a role in dragging Pacifica beneath the ocean. Unlike other land masses that were swallowed by rising sea levels, this wasn't just a case of flooding. Scientists believe that Pacifica was forced downward by a process known as subduction, where one tectonic plate slowly pushes another down into the mantle over millions of years. It's a process that typically happens to oceanic plates, not continents, which makes this discovery even more bizarre. To put this in perspective, imagine standing on solid ground, feeling the earth beneath your feet, and knowing that, in some distant future, this entire landmass could vanish, pulled downward into the earth itself. That's exactly what happened to Pacifica. At some point in Earth's history, this continent wasn't just real, it was thriving. It may have been covered in vast forests, carved by deep rivers, home to creatures that have long since gone extinct. Some scientists even suggest that Pacifica might have been part of an ancient supercontinent that existed before Pangaea, one that broke apart and vanished so completely that we never even knew it existed. The implications of this discovery are massive. If Pacifica was once above water, it may have played a role in early animal migration, shaping the way life evolved on Earth. Some researchers speculate that fossil records from nearby islands, places like New Zealand, New Caledonia, and Fiji, could hold clues about what kind of creatures once roamed Pacifica. Could it have been home to giant megafauna, towering ferns, and ecosystems unlike anything we've ever seen? Could it have been a stepping stone for early human migration, long before recorded history? And here's where things get really interesting. If a continent this massive could disappear and remain hidden for so long, How many other lost continents could be lurking beneath the ocean? What else have we missed? The more we map the ocean floor, the more we realize that Earth's history is far more complex than we ever imagined. And if Pasifia was lost to time, what other secrets might be buried beneath the waves, waiting to be discovered? Consider this: over 70% of Earth is covered in water, yet we've mapped only a fraction of the ocean floor in any real detail. While satellites can provide us with broad outlines, the true topography of the deep sea remains largely a mystery. The vast, crushing pressures of the deep ocean make it incredibly difficult to explore, and because of that, most of the seabed remains uncharted. Scientists estimate that less than 20% of the ocean floor has been mapped with high resolution, meaning that lost continents, hidden mountain ranges, and even remnants of ancient land bridges could still be out there, completely unknown to us. But what's even more mind-blowing is the possibility that Pasifia wasn't just a barren landmass. It might have been home to an ancient civilization. While that idea might sound like something out of myth and legend, it's not as far-fetched as you might think. Throughout history, countless stories have been passed down about sunken lands swallowed by the sea. The most famous of these, of course, is Atlantis, a civilization that, according to legend, vanished beneath the ocean in a single cataclysmic event. Could the discovery of Pasifia lend some truth to these ancient tales? While no direct evidence of human civilization has been found on Pasifia, at least not yet, scientists are beginning to look at nearby islands for clues. New Zealand, for example, is one of the few remnants of a once great landmass that existed long ago, and it shares some geological similarities with Pasifia. Could it be that Pasifia was once part of a larger chain of islands, some of which still remain above water today? And if that's the case, could the ancestors of early humans have once lived on these lands, only to be displaced when rising seas or shifting tectonic forces pulled their homeland beneath the waves? This is where the mystery deepens. If Pasifia was once a thriving landmass, it may have left behind evidence, traces of ancient life, fossilized remains, or even signs of early human activity buried beneath layers of sediment. Scientists are now eager to send submersibles and deep-sea exploration teams to the region, hoping to uncover anything that might tell us more about this lost world. But there's another challenge: time. The ocean is a powerful, ever-changing force, and anything that was once on Pasifia's surface may have been eroded, buried, or broken down by millions of years of geological activity. Underwater currents have likely carried away much of what once existed. All layers of silt and volcanic ash may have buried what remains. This means that finding concrete evidence of Pasifia's past will be no easy task. It's a race against nature itself. Still, history tells us that lost worlds have been rediscovered before. Take Doggerland, for example, a massive stretch of land that once connected Britain to mainland Europe before it was swallowed by rising seas around 8,000 years ago. For centuries, people believed that the North Sea had always been there, until archaeologists uncovered proof that an entire prehistoric landscape had existed beneath the waves, complete with rivers, forests, and even evidence of human habitation. If Doggerland could be rediscovered after thousands of years, then why not Pasifia? Now, how could this have happened? One of the most compelling explanations for the disappearance of Pasifia beneath the waves is tectonic activity, and the slow but relentless movement of Earth's plates. While the ground beneath our feet may seem solid and unchanging, the reality is far different. Earth's crust is constantly shifting, albeit at a pace that's often imperceptible over the course of a single human lifetime. The entire surface of our planet is made up of massive, interlocking plates that float on the semi-molten rock of the mantle, moving ever so slightly each year due to the immense forces generated beneath them. When these plates collide, separate, or grind past one another, the results can be catastrophic, leading to earthquakes, volcanic eruptions, and even the gradual destruction of entire land masses. To understand how tectonic forces could have swallowed Pasifia, we need to look at a concept known as subduction, a process where one tectonic plate is forced beneath another, sinking into the mantle and eventually being recycled into Earth's interior. This occurs most often at convergent plate boundaries, where two plates are slowly being pushed together by the inexorable forces of mantle convection. Over millions of years, the heavier of the two plates is gradually dragged downward, disappearing into the depths of the planet, while the overriding plate continues to move above it. The Pacific Ocean is home to some of the most active subduction zones on Earth, particularly along the infamous Ring of Fire, a massive horseshoe-shaped belt of volcanic and seismic activity that encircles the Pacific Ocean. If Pasifia was located near one of these subduction zones, it's possible that it was slowly but steadily drawn beneath the surface over the course of millions of years, vanishing from sight as the heavier oceanic crust reclaimed the land. But subduction isn't a fast process. It takes millions, if not tens of millions, of years for an entire landmass to be fully submerged. This means that if Pasifia was once above sea level, its disappearance wouldn't have been a sudden cataclysmic event like a massive flood or an asteroid impact, but rather a slow and steady descent into the ocean, occurring so gradually that no single generation of life on Earth would have noticed the change. Instead, over thousands of years, coastlines would have eroded, mountain peaks would have disappeared beneath the waves, and islands would have broken apart, until finally, what was once a vast and thriving landmass had been reduced to nothing more than a scattered collection of submerged plateaus and ridges beneath the ocean's surface. One of the strongest pieces of evidence supporting the idea that tectonic activity swallowed Pasifia comes from studies of Zealandia, a nearly submerged continent in the southwestern Pacific that shares striking similarities with the theoretical landmass of Pasifia. Scientists believe that Zealandia was once a part of the larger supercontinent of Gondwana before tectonic forces pulled it away and gradually lowered it beneath the sea over tens of millions of years. Today, only a fraction of Zealandia remains above water, New Zealand and a few scattered islands, while the rest lies hidden beneath the waves, a ghostly remnant of a once great land. If a similar process occurred with Pasifia, then it's entirely plausible that an entire continent-sized region could have been erased from the surface of the Earth without leaving behind obvious signs of its existence. Further evidence of tectonic activity's role in the disappearance of Pasifia can be found in the deep-sea trenches and underwater mountain chains that crisscross the Pacific Ocean. These vast geological features tell a story of constant motion, of land rising and falling over eons as the plates shift and reshape the planet's surface. Some scientists speculate that Pasifia might have once been an extension of an ancient land bridge, a vast expanse of land that once connected different regions of the world before tectonic activity fractured and submerged it beneath the waves. If so, it's possible that remnants of Pasifia still exist as isolated underwater plateaus or seamounts, hidden beneath miles of water and sediment, waiting to be rediscovered. Of course, if tectonic forces were truly responsible for the sinking of Pasifia, it raises even more questions. Could other lost landmasses have suffered a similar fate? If entire continents can be slowly swallowed by the planet, then what else has been erased from history? How many forgotten landscapes, along with whatever plants, animals, and possibly even civilizations once inhabited them, have been lost to time, hidden beneath the depths of our oceans? And more importantly, what would it take to uncover them again? The possibility that a massive, sprawling landmass could simply disappear due to the unyielding movement of Earth's crust is both awe-inspiring and deeply unsettling. It serves as a reminder that our planet is constantly changing, reshaping itself in ways that we can barely comprehend. And while we may think of the continents as fixed and permanent, the truth is that nothing on Earth lasts forever. Just as new land can rise from the sea, through volcanic activity and the slow accumulation of sediment, so too can ancient landmasses vanish beneath the waves, leaving behind only whispers of their existence. Continuing from the tectonic activity theory, another aspect to consider is the influence of seismic events that could have further accelerated the process of subduction, pushing Pasifia's landmass beneath the waves at a faster rate. Earthquakes, often a result of tectonic plate movements, can generate tremendous forces that affect the integrity of the land above and below the ocean's surface. Though earthquakes themselves are brief events, the aftermath can have long-term impacts on the land. A massive earthquake occurring along the plate boundaries near Pasifia could have triggered large-scale subsidence, where the land slowly sinks or collapses into the ocean. This subsidence would not be uniform, but rather a gradual, ongoing process, with some regions of Pasifia sinking faster than others, leading to the slow disappearance of the landmass over millennia. Further contributing to this process is the formation of fault lines and their role in land deformation. Faults are fractures in the Earth's crust where tectonic plates meet and slide past one another. Over time, these faults can cause large blocks of land to shift vertically, often resulting in parts of a landmass being pulled downward into the depths. If Pasifia were situated along a major fault line, this could explain why certain areas of the land began to sink, eventually leading to the entire landmass being engulfed by the ocean. The continuous movement of the tectonic plates would have meant that Pasifia was constantly subjected to minor tremors and larger seismic shifts, gradually causing the land to erode, break apart, and subside into the ocean floor. One particularly fascinating aspect of this process is how underwater mountain chains could play a role in the subduction of a continent like Pasifia. As tectonic plates move, they not only cause earthquakes but can also give rise to oceanic ridges and mountain chains beneath the sea. These underwater mountains are formed when two tectonic plates diverge, allowing magma from beneath the Earth's surface to rise and solidify. However, when plates collide or one is forced beneath the other, these mountain ranges may also collapse or be buried, contributing to the disappearance of once thriving landmasses. If Pasifia were near a convergent plate boundary, these underwater mountain ranges could have acted as a barrier, shifting the landscape, altering sea levels, and contributing to the erosion of the land. In the process of subduction, the deformation of the Earth's crust would have also led to the formation of deep-sea trenches, some of the most profound features on Earth's surface. The Mariana Trench, for example, is the deepest oceanic trench in the world, formed as one tectonic plate subducted beneath another. If Pasifia was located near such a subduction zone, it's plausible that the landmass began to be drawn downward, pushed into these deep oceanic trenches, where the crust was stretched, folded, and eventually pulled into the mantle. The resulting void left in the wake of Pasifia's disappearance could explain why so little physical evidence remains above the surface today. The gradual nature of the process would mean that Pasifia didn't just vanish overnight, but was eroded and displaced over an immense period of time. Additionally, the depth and complexity of oceanic trenches can also impact the way land masses sink. As plates interact with the mantle below, heat and pressure increase, causing the crust to weaken. This weakening can create irregularities in the sinking process, where large portions of land might remain suspended for long periods, only to suddenly collapse into the ocean after a massive seismic shift. The bottom of the ocean is not a simple flat plain, but rather a series of highly variable geological features, from towering mountains to expansive plains. Thus, the slow subduction of Pasifia could have resulted in vast underwater plateaus, now buried beneath hundreds or thousands of feet of water and sediment. One other critical factor that could have played a role in the sinking of Pasifia is the rate at which tectonic plates move. The average rate of movement for most tectonic plates is about 2 to 4 centimeters per year, which seems slow but adds up to several meters over thousands of years. Given the immense size of Pasifia, it's likely that the entire landmass slowly slipped into the ocean over millions of years. During this period, the rate of subduction would have fluctuated due to the complex interactions between the plates. Certain regions of the land could have been more susceptible to sinking, while other areas might have remained above sea level for extended periods. This patchwork effect of gradual submergence would make it difficult to pinpoint when exactly Pasifia disappeared beneath the waves. The interaction of tectonic and volcanic activity could have further compounded the effects on Pasifia. When tectonic plates shift, the pressure beneath them can sometimes cause volcanic eruptions. If these eruptions occurred near the edges of Pasifia, they might have contributed to both the subduction and the erosion of the landmass. Volcanic islands often form when magma from the mantle rises through fissures in the Earth's crust, creating new land. However, in the case of a landmass sinking, volcanic eruptions could have been a double-edged sword. They may have caused parts of Pasifia to break apart even more quickly, while simultaneously contributing to the formation of new oceanic features like seamounts or volcanic islands. These eruptions could have accelerated the process of sinking, especially if they occurred along fault lines where the tectonic plates were already under immense pressure. What makes the idea of tectonic activity such a compelling explanation for the disappearance of Pasifia is the sheer scope and timeframe involved. Tectonic forces don't work on a human scale. They operate over millions of years, reshaping the very surface of our planet. The forces that cause landmasses to sink beneath the waves are often invisible to the naked eye, but their effects are undeniable. If Pasifia was indeed affected by these forces, then it's likely that the landmass gradually became a victim of the relentless, slow-moving tectonic processes that shape our world. What was once a thriving continent may have simply been overwhelmed by the natural forces of the Earth, lost beneath the waves over an unfathomable period of time, with no trace left behind except for the ripples in the ocean and the silent remnants of a vanished world beneath the sea. As we consider these possibilities, we must remember that Earth is an ever-changing, dynamic system, where even the most stable and immovable-looking features of the planet can be altered by the constant and unstoppable forces at play beneath the surface. The disappearance of Pasifia is not just an anomaly in Earth's history, it is part of the natural, ongoing cycle of creation and destruction that has shaped our planet for billions of years. And as scientists continue to study the geological history of the Earth, they may uncover even more clues that reveal the true extent of tectonic forces in shaping the world as we know it today. Shifting our focus to another potential theory, it's possible that a catastrophic climatic event could have also contributed significantly to the gradual disappearance of Pasifia. Climate, as we know, is not a static phenomenon. It's deeply influenced by a multitude of factors, ranging from atmospheric composition to ocean currents, and even to solar activity. In the case of Pasifia, a sudden or gradual shift in climate conditions could have caused environmental stress that, in combination with the tectonic activity, accelerated the land's sinking and eventual disappearance beneath the waves. One plausible scenario is a global cooling event, or even the onset of an ice age that drastically altered the sea levels around Pasifia. The Earth has experienced several ice ages in its long history, periods in which vast portions of the planet's water became trapped in massive ice sheets. As glaciers expanded, they drew down sea levels, exposing large expanses of land. However, as these ice sheets eventually melted during warmer interglacial periods, the sea levels would have risen once again, flooding previously exposed landmasses. If Pasifia was situated in a region susceptible to such fluctuations, the rise in sea levels could have been a key factor in its submergence. During an ice age, the Earth's temperature would plummet, leading to a dramatic shift in weather patterns. As the polar ice caps expanded, they would have drawn moisture from the atmosphere, causing more severe and persistent winters. Areas near the equator, where Pasifia might have been located, would experience significant shifts in their climate as well. If a prolonged cooling period occurred, this could have caused rivers, lakes, and coastal areas to freeze, limiting the land's ability to sustain life. The once thriving ecosystems of Pasifia would have been destabilized, triggering a cascade of environmental events, including the gradual erosion of the land. Additionally, during such climatic upheavals, stronger and more frequent storms could have impacted the coastal regions of Pasifia. Hurricanes, typhoons, and monsoons are all exacerbated by changes in ocean temperatures and atmospheric pressure. As climate patterns shifted, the violent storms could have battered the coastline relentlessly, gradually eroding the land and even contributing to the sinking of some areas. Over time, this steady barrage of natural forces would wear away at the land's stability, pushing the island into further decline. Coastal erosion, which is a natural process even today, would have been intensified during periods of severe climate change, further weakening the land's ability to resist the forces of the ocean. Another important factor in this climatic shift could have been the impact of volcanic activity on the atmosphere. If Pasifia was situated near tectonic boundaries where volcanic eruptions were common, it's possible that a series of massive volcanic eruptions could have triggered a volcanic winter, a period in which the Earth's climate cools dramatically due to the large volumes of ash and sulfur dioxide ejected into the atmosphere. These particles can block sunlight, leading to cooler global temperatures and disrupted weather patterns. Such an event could have plunged Pasifia into an extended period of cold temperatures, perhaps triggering ice formation along its coasts. As the climate became colder, the land could have experienced a combination of freezing and thawing, which accelerates erosion and destabilizes the foundation of the land itself. In addition to volcanic eruptions, another source of climate disturbance could have been massive shifts in ocean currents. Ocean currents play a crucial role in regulating the global climate by redistributing heat around the planet. A disruption in these currents, caused by a combination of shifting tectonic plates and changing atmospheric conditions, could have dramatically altered weather patterns. For instance, if the currents that once helped moderate Pacifia's climate shifted, the region could have experienced extreme temperature swings. Areas once temperate could have become unbearably hot or frozen, making it difficult for ecosystems to survive. As the land's ecosystems weakened and its resources dwindled, the landmass would have become increasingly uninhabitable, making its eventual disappearance into the ocean even more likely. Changes in the composition of the atmosphere during a dramatic climate shift could have also been a contributing factor to the collapse of Pacifica. For example, the increase in carbon dioxide or other greenhouse gases could have triggered a runaway greenhouse effect, causing temperatures to rise and flooding the land. Even a slight increase in global temperatures would be enough to melt ice sheets, raising sea levels and submerging large swaths of coastal land. If this warming coincided with the tectonic movements pushing Pacifica towards subduction zones, the combination of rising seas and sinking land could explain why Pacifica eventually disappeared beneath the waves. On the flip side, if the cooling event was severe enough, it could have led to an extended winter period. The Earth could have entered a period where temperatures dropped significantly for long durations, allowing snow and ice to accumulate along the land's edges. This would have created a vicious cycle. Colder temperatures would increase the formation of ice, which would increase the weight on the land, causing it to sink further. The buildup of ice would act like a pressure that slowly pushed the land downward, contributing to the gradual subduction of Pacifica. Droughts and a reduction in freshwater sources could have further complicated matters. During extreme climatic shifts, regions that were once fertile and capable of sustaining human and animal life could experience long-lasting droughts. The rivers and lakes that once fed Pacifica's agriculture could have dried up, causing widespread famine and environmental distress. The lack of water would not only lead to the collapse of ecosystems, but would also weaken the structural integrity of the land. In some areas, the land would have cracked and eroded, exposing it to further submersion. These combined forces could have resulted in the landmass being slowly pulled beneath the ocean's surface, lost to time and climate change. As we continue to explore the theory of a dramatic climatic shift contributing to the eventual sinking of Pacifica, another factor worth considering is the potential role of atmospheric circulation patterns and how they could have dramatically altered the weather in this region. Atmospheric circulation, which is responsible for the movement of air masses and the distribution of heat around the globe, is incredibly sensitive to changes in the Earth's surface temperature and ocean currents. Any disruption in these systems could have led to unpredictable weather patterns and extreme temperature variations, both of which would have had severe consequences for Pacifica. For instance, if Pacifica was located in a region where the shifting climate caused the jet stream, the fast-moving air currents high in the atmosphere, to change its course, it could have brought about prolonged periods of extreme weather. The jet stream plays a crucial role in regulating the weather, as it helps to control the flow of air from the equator to the poles, balancing temperatures around the world. A shift in the jet stream could result in persistent heat waves, prolonged droughts, or unseasonably cold spells. Such extreme conditions would have had a profound impact on the ecosystems of Pacifica, particularly on its agriculture and freshwater sources. In turn, this could have led to massive disruptions in the local food chain, diminishing the land's ability to support life and making it more susceptible to further erosion or even sinking due to weakened geological stability. Moreover, another atmospheric effect that might have played a significant role in Pacifica's demise is the reduction of solar radiation due to volcanic activity or increased cloud cover caused by climatic disturbances. After a series of volcanic eruptions, the Earth's atmosphere could have been flooded with sulfur aerosols or ash particles, which block out sunlight and lead to a phenomenon known as volcanic winter. This cooling effect would not only lower global temperatures but could have altered precipitation patterns, reducing rainfall in areas that were once fertile and sustaining life. If Pacifica relied on consistent rainfall to feed its rivers and lakes, a sudden and dramatic reduction in precipitation could have caused water sources to dry up, leading to further environmental stress and erosion. Without access to fresh water, agriculture would have collapsed, and local wildlife would have struggled to survive. Another key element to consider in this shift would be the change in ocean salinity and circulation. Ocean currents play an essential role in regulating global climates, as they help distribute heat across the planet. If the dramatic climatic event led to changes in ocean salinity, perhaps caused by the melting of ice sheets or altered rainfall patterns, it could have disrupted major ocean currents, like the Gulf Stream. The Gulf Stream, for example, transports warm water from the tropics to the North Atlantic, which helps maintain mild temperatures in the northern hemisphere. A disruption in such currents could have led to colder temperatures around the mid-latitudes and further stressed Pacifica's already changing climate. If the surrounding seas cooled dramatically, the island would have been subjected to stronger winds and violent storms, further eroding its coastlines and contributing to its eventual submergence. The dynamic shifts in ocean circulation would have meant that temperatures and weather patterns became increasingly erratic, making it impossible for the land to maintain its delicate balance. On top of that, these extreme climatic shifts could have triggered massive migrations of species, both terrestrial and marine, which would have had a cascading effect on Pacifica's ecosystems. As the climate began to cool or warm dramatically, species would have sought refuge in more hospitable environments. While this would have caused some species to leave, it could also have led to the introduction of new species that were better adapted to the changing conditions. This sudden influx of foreign species could have disrupted existing ecosystems, leading to competition for resources and forcing the native species to compete for food, water, and space. This ecological disruption could have weakened the island's biodiversity, making it harder for the environment to sustain life. With fewer species able to adapt, the land would have faced even greater pressure to support its population, which could have led to a further breakdown of the ecosystems, hastening its collapse. Simultaneously, changes in air pressure systems could have contributed to the instability of the region. Air pressure patterns are heavily influenced by temperature variations across the Earth's surface. A dramatic cooling of the planet, or a shift in temperature due to volcanic activity or solar radiation changes, could have led to unpredictable storm systems that wreaked havoc on the land. As pressure systems became more volatile, this would have triggered intense storms, including cyclones or typhoons, that could have pounded Pacifica's coastlines with high winds, heavy rainfall, and intense flooding. The damage caused by these storms could have taken its toll on the island's fragile infrastructure, making it harder for the inhabitants to recover from such destructive events. These extreme shifts in atmospheric pressure and weather patterns would have intensified coastal erosion, a process that would already have been exacerbated by the rising sea levels. As the weather became more severe and unpredictable, it would have hastened the island's erosion, particularly at the most vulnerable coastal areas. With heavy rains and flooding becoming more frequent, the land would have become increasingly unstable. The constant battering from storms, along with the already heightened risk of tectonic shifts, could have created the perfect storm of events, pulling the island further beneath the ocean's surface. Lastly, the feedback loops that climate change can trigger are particularly concerning. For instance, as temperatures increase or decrease, this could trigger the release of greenhouse gases such as methane from thawing permafrost or from the deep ocean. Methane, being a potent greenhouse gas, would have further accelerated global warming, creating a vicious cycle of rising temperatures and melting ice. Alternatively, if the region cooled dramatically, the land could have been covered in glaciers, increasing the weight and pressure on the land, pushing it closer to subduction zones. These feedback loops would have compounded the damage caused by other climatic factors, such as shifting air and ocean currents, volcanic eruptions, and increased storm activity, contributing to Pacifica's gradual disappearance into the ocean. In essence, the combination of these climatic disturbances, whether caused by solar radiation changes, volcanic eruptions, shifts in ocean currents, or atmospheric pressure fluctuations could have caused a perfect storm of environmental stress. As these forces combined, they would have created a situation in which the landmass of Pacifica, already fragile due to tectonic instability, was further destabilized. The inability of the land to withstand the brutal environmental changes, coupled with rising sea levels and intense storms, could have led to the island's eventual sinking. As we've just explored, the dramatic shift in climate played a pivotal role in destabilizing the ecosystems and infrastructure of Pacifica. Yet, perhaps one of the most pressing and inevitable consequences of these climatic disturbances was the rising sea levels that gradually encroached upon the island, hastening its eventual submergence. The rising sea levels were not just a distant possibility, but a very real threat that was directly influenced by both natural and human-induced changes to the Earth's climate system. As the climate warmed and cooling periods alternated with extreme storms, the dynamics of ocean water levels began to shift, creating a situation in which the island's once secure shores were relentlessly under threat. The theory of rising sea levels is fundamentally tied to the melting of polar ice caps and glaciers, a process that accelerates when the Earth's average temperature increases. As we saw with the cooling and warming cycles that shook the island, the impact of these shifts on the global climate would have been immediate and profound. The polar ice caps, primarily located in the Arctic and Antarctic regions, hold vast quantities of fresh water. As these ice masses began to melt, they contributed large volumes of water into the oceans, raising the overall sea level. This gradual yet steady increase in water volume, driven by the complex dynamics of the Earth's shifting climate, put immense pressure on low-lying coastal areas like those of Pacifica. It's not just the melting ice that contributes to rising sea levels. As the ocean water itself warms up due to higher global temperatures, it undergoes thermal expansion, meaning the water molecules spread out and occupy more space. This expansion would have been particularly significant around the equator, where the warming ocean temperatures are most pronounced. As the seas expanded due to thermal changes, coastlines that once seemed secure were now under threat. The combination of the expanding oceans and the influx of water from melting ice would have led to gradual but unstoppable encroachment on Pacifica's shores. Areas that were once protected from the ocean's tides by natural barriers, such as coral reefs or sea cliffs, began to erode faster than ever before, exposing vulnerable stretches of the coastline to the relentless push of the rising sea. The rising sea levels would not have been a sudden event, but rather an ongoing phenomenon, taking place over decades or even centuries. However, the sheer inevitability of the process would have created a creeping sense of desperation among the inhabitants of Pacifica. Tidal surges and storm surges, which are often linked to rising sea levels, would have intensified dramatically. With each passing year, the storms that lashed the island became more frequent and more violent. The island's infrastructure, weakened by both climate and tectonic factors, would have struggled to cope with the increased saltwater intrusion into freshwater sources and agricultural lands. Even the most robust buildings and structures would have been slowly undermined by the steady rise of ocean water, eroding foundations and causing significant damage over time. At the same time, rising sea levels would have triggered a loss of biodiversity, especially in coastal regions that rely on a delicate balance of ecosystems. Mangroves, salt marshes, and other coastal habitats are not only crucial for wildlife but also serve as natural barriers that protect land from the full force of the ocean. As sea levels rose, these vital ecosystems would have been submerged, leaving the island increasingly exposed to the destructive forces of the ocean. In many parts of the world, when rising sea levels submerge these critical habitats, they create a feedback loop in which coastal erosion accelerates, making it even harder for the land to recover. This same principle would have applied to Pacifica, where the erosion of the coastal buffer zones would have only worsened the impact of the rising waters. The island's freshwater systems, rivers, lakes, and underground aquifers, were also at risk from the rising tides. Saltwater intrusion would have become an increasing problem as the ocean breached the shoreline and began to infiltrate the freshwater systems. Saltwater in drinking water sources is not only dangerous to human health but also devastating for agriculture, as crops and vegetation cannot survive with saline water. This contamination would have resulted in massive water scarcity, a critical issue for any population. As fresh water supplies dwindled and the fertile soil turned saline, the island's ability to support its population would have eroded along with its land. One key element to consider here is the rate of sea level rise during this period. Studies have shown that during past periods of rapid climate change, sea levels have risen at an alarming rate, sometimes as much as several meters per century. Even if Pasifia experienced a moderate rise in sea level of a few feet per century, this would have been more than enough to significantly impact the coastal areas, particularly if the island was already experiencing other environmental stresses, such as volcanic activity or tectonic shifts. Over time, the combination of these forces would have led to a gradual inundation of the island, transforming once fertile lands into underwater tombs. Another critical point is that rising sea levels would not have been uniform across the entire planet. Local variations in the rate of sea level rise would have depended on factors such as ocean currents, geographical location, and the topography of the land. Areas near the equator, where the ocean water is warmer and the ice melt is more pronounced, would have been particularly vulnerable to rapid encroachment. This could have meant that Pasifia, being located in a region subject to these changes, saw its coastline erode at a much faster pace than other islands in the region. In some cases, this may have been compounded by tectonic subsidence, where the land itself was sinking due to the combined weight of the rising water and geological shifts, accelerating the process of submersion. In the final stages, the island may have found itself surrounded by water on all sides, with only the highest peaks and ridges remaining visible above the surface. In many cases of islands sinking due to rising sea levels, these final remnants are often referred to as sea stacks or islets, isolated and exposed to the full force of the ocean. As the last traces of Pasifia's once vibrant landmass sank beneath the waves, it would have been a stark reminder of the relentless power of nature and the unpredictable forces at play in our planet's climate system. The combination of thermal expansion, ice melt, and geological instability would have made the island's eventual submersion all but inevitable, leaving behind only the ghostly whispers of a civilization lost to time. As we consider the fate of Pasifia and the forces that led to its submergence, it's impossible not to turn our gaze toward the broader implications for humanity. The story of Pasifia is not just an isolated tragedy. It serves as a haunting warning of what could lie ahead for other vulnerable coastal regions around the world. If the sinking of a civilization as advanced and resourceful as Pasifia could happen, what might the future hold for the rest of us? This scenario compels us to ask fundamental questions about the sustainability of our current way of life and the long-term consequences of environmental degradation. First and foremost, the rise in sea levels serves as a glaring reminder of the fragility of coastal cities. Nearly 40% of the world's population lives within 100 kilometers of the coast, with many of the world's largest and most economically significant cities perched on these vulnerable shorelines. From New York City to Shanghai, Mumbai to London, these cities represent the heart of global trade, culture, and innovation. Yet, they also face the existential threat of rising waters that could one day swallow them, just as they did with Pasifia. The potential for mass displacement is one of the most immediate and alarming consequences of this threat. Humanity's increasing dependence on coastal infrastructure makes us particularly susceptible to rising sea levels. From shipping ports and airports to energy plants and water treatment facilities, much of our critical infrastructure is built at or near sea level. If these facilities were to be overwhelmed by the ocean, the disruption could be catastrophic, not just for the local population, but for the global economy. Supply chains, for example, could be severed, creating food shortages and economic turmoil. Transportation routes, which rely on access to coastlines, would be crippled, and power outages could become more frequent and widespread, exacerbating the crisis. The migration crisis that would follow the submersion of coastal regions is another significant consequence that humanity would have to contend with. As millions of people are displaced from their homes, either temporarily or permanently, the pressure on inland areas would be immense. The sheer scale of such a migration would strain resources, healthcare systems, and housing markets across vast regions. In some cases, whole nations could face the difficult choice of whether to accept refugees from the sinking coastal cities or to focus on their own survival. This would no doubt lead to heightened tensions between countries, as the struggle for limited resources could spark new conflicts and geopolitical instability. As we look beyond the immediate human toll, we must also consider the cultural impact. The loss of entire cities, communities, and ways of life would lead to the erasure of centuries of history. Much like Pasifia, where the civilization's legacy and achievements would be buried beneath the ocean, coastal cities that once served as the birthplaces of art, literature, and scientific discovery could be lost to time. Museums, libraries, and archives that house invaluable cultural heritage could vanish in an instant. The disappearance of these cultural hubs would be a blow not only to the people who lived there but to humanity as a whole. It would be a tragic reminder of how fragile the connections we take for granted can be. What's more, the sinking of coastlines and the destruction of cities would force a fundamental shift in the way we think about urban planning and resilience. In the face of rising sea levels, humanity would need to rethink its approach to development. Cities may need to be restructured, with new architecture designed to withstand floods and storms, and with the capacity to rise above the increasing waters. Building materials and urban designs that have long been the norm might need to be replaced with more durable, water-resistant alternatives. Above all, the very concept of sustainability would have to evolve, focusing not only on conservation and environmental impact but also on survival in the face of an ever-changing planet. The situation would also challenge humanity's ability to adapt to an environment that no longer behaves predictably. The slow onset of rising seas gives us a window of time to prepare, but preparation requires resources, infrastructure, and foresight, things that many nations, especially those already facing economic challenges, may not have at their disposal. The question of whether we can adapt fast enough to stave off disaster would be at the forefront of global discussions. If past patterns of behavior are any indication, humanity's responses may be too little, too late. History has shown that when faced with the overwhelming scope of environmental change, people often delay action or fail to recognize the full extent of the threat until it is too late. At the same time, humanity's focus would inevitably shift toward innovation. Faced with the reality of a changing climate and rising seas, the world would be compelled to turn to science and technology for solutions. Geoengineering concepts, such as building massive sea walls or even attempting to manipulate the climate itself, would likely be explored, though they come with their own set of ethical and practical challenges. Innovations in water management, flood protection, and sustainable architecture could rise to prominence, offering some hope of mitigating the damage. However, whether these technologies could be scaled quickly enough to prevent widespread destruction remains an open question. Perhaps one of the most profound impacts of a scenario like this would be the shift in human consciousness. The realization that we are not separate from the planet, but rather intricately tied to it, could spark a global awakening. The loss of a place like Pasifia, or any other coastal region, could serve as a symbolic wake-up call for humanity, urging us to recognize that our actions today will have long-lasting consequences. It could inspire a generation to prioritize environmental stewardship, to seek balance with nature, and to invest in the health of our planet as the foundation for future generations. In the face of potential collapse, the survival of humanity might depend not just on our technological advances, but on our ability to reconnect with the Earth and the lessons it offers. Ultimately, the fall of Pasifia could be seen as a tragic chapter in a larger narrative about humanity's struggle for survival. It would serve as a stark reminder that no matter how advanced we become or how much we control, we are still at the mercy of the natural world. What happens to us in the future, when faced with the rising seas and the unpredictable forces of nature, will depend on how we respond now. The choices we make today will determine the fate of future civilizations, just as the inhabitants of Pasifia's civilization were ultimately powerless to prevent their land from sinking beneath the waves. The clock is ticking, and the actions we take, or fail to take, will shape the course of humanity for generations to come. As we draw to a close, it's important to reflect on the journey we've taken together through the unsettling yet fascinating exploration of how rising sea levels and climate change could dramatically reshape our planet. From the geological forces beneath our feet to the shifting climate patterns that threaten to upend centuries of human development, we've examined a wide array of factors contributing to this inevitable shift. It's a reminder of how interconnected our world is, and how vulnerable we truly are in the face of nature's immense power. We've discussed the tectonic forces that are pushing our planet's crust into new configurations, raising land and shifting coastlines in ways that we may not fully comprehend until the changes are irreversible. We've expanded on how volcanic activity, shifting fault lines, and the buildup of stress in the Earth's lithosphere could lead to sudden, cataclysmic events that affect everything from sea levels to climate systems. In tandem, we've examined how these geological events could spark cascading climate shifts, where warming oceans and rising greenhouse gases spiral into an accelerated cycle, further exacerbating the crisis. Through this, we've seen the dual threat of nature's violence, the rising oceans and the tempestuous storms that would accompany them, making their presence felt long before the full impact is realized. As the seas encroach upon coastal regions, we've considered the impact on human civilization, how millions of people might be displaced, their homes, livelihoods, and cultures swallowed by the inexorable tide. The complex task of managing this migration and securing resources for those fleeing devastated lands would not be easy. And yet, despite the challenges, there may also be opportunities for us to rebuild in smarter, more sustainable ways. Cities of the future could emerge from this crisis as hubs of innovation, where technology and human ingenuity combine to create floating communities, self-sustaining ecosystems, and resilient infrastructure designed to thrive amidst the forces of nature. Innovation and collaboration, however, will be essential for humanity to overcome the chaos. Yet, as we've seen, the rising seas bring with them much more than just the loss of land. They could lead to profound geopolitical shifts, the destabilization of economies, and the rise of new power structures. Nations once thought secure may find themselves on the front lines of a crisis they cannot fully control, while others may rise to prominence, offering solutions or refuge to the displaced. The climate refugee crisis, alongside economic and social upheaval, could redefine the fabric of our global society in ways we're only beginning to understand. But perhaps, the most important takeaway from our discussion is that we must act now. The science, the evidence, and the warnings are clear. Rising sea levels and climate change are not distant possibilities. They are here, and they are happening. It's time for global cooperation on an unprecedented scale. This crisis won't wait for us to be ready. Whether through better policy, technological innovation, or a drastic shift in our global consciousness, the key to surviving and adapting lies within our collective action. We cannot afford to ignore the signs any longer. As we step forward, let us hold on to hope. Hope that through unity, through the tireless work of scientists, engineers, and activists, we can begin to turn the tide. It's up to us to adapt, to protect our world, and to create a future where humanity can thrive, not despite the challenges we face, but because we have risen to meet them head-on. If you've been captivated by the depths of this topic, if it has sparked thoughts about the future of our planet, the choices we make today will determine our tomorrow. Please take a moment to like this video if you found it thought-provoking, and don't forget to subscribe to the channel for more insights on how we can navigate these turbulent times. As always, share your thoughts in the comments below. Let's keep the conversation going and share ideas about how we, together, can make a difference. Stay informed, stay engaged, and most importantly, stay prepared.